Hello everyone, welcome to Unravel Logic channel. In today's video, we will cover the concept of p-values. As a prerequisite, it is good to have an understanding of percentiles, which I have covered in my previous video. As usual, let us start with the definition. So p-value is a measure of how unusual or rare a given value is within a set of values. It is like a measure of extremeness. Measure of extremeness, or how rare or unusual a value is in a given dataset. The reason I'm writing this in different color is because this is important. In a given dataset. P-value is of three types. Okay. Types of p-values. We have upper tailed p-value, lower tailed p-value, and two-tailed p-value. So we'll understand each of these using an example, and then you would understand the formal definition as well in a better way. Okay, but let us go ahead and understand each of these using a simple example. So as an example, let us say we have the following exam scores. Okay, so we have a set of exam scores, and that would be our data set for understanding all three kinds of p-values and the concept of p-value overall. Okay, so this is the exam scores of different students. Okay, and let us say that you scored 90 marks and want to know if this is an unusual score compared to other scores in the data set. So let us say that this was a very big data set and you had no way to see all the other scores, and you just know your score, but you want to compare how unusual your score is. Is it very rare? Is it very common? Is it very rare on a higher side, or is it very rare on a lower side? And you want to compare this. So how would you do this? Okay, you scored 90, want to know how common, rare your score is. So let us find the p-value of how many scores are greater than or equal to 90, which is your score. Okay, so p-value. So p-value, as we discussed in our formal definition, that it's a measure of extremeness. So what is the extremeness of any score being greater than or equal to 90? Okay, p-value for score greater than equal to 90. This is called as upper tailed p-value. Okay, greater than or equal to would mean upper tailed p-value. So upper is in greater than or equal to. Upper, which is higher. So greater, that is higher. This is one way to remember it. Okay. So what is the p-value of how many scores are greater than equal to 90? Okay. So to calculate this, what we need to find out is how many scores are greater than or equal to 90 in our data set. So that would mean 3 scores. So 90, 95 and 100. So these are the 3 scores which are greater than or equal to 90. So 3 scores which are greater than equal to 90. How many are the total scores? Total number of scores. Total scores equal to 13. So if you count, these are 13 scores we have. Okay. And what is the share of values which are greater than or equal to 90? So the simple way to do this is to do, so upper tailed p-value would be 3 over 13, which would approximately come as 0.23. Okay. So this is the p-value of scores which are greater than or equal to 90. So around 23% scores are higher or as high as 90. Okay. So this is like a probability. Okay. So 23% scores are higher or as high as 90. So the reason we are writing as high as 90 is that all of these scores, or for example, there can be, for example, all these 23% of these scores can be as high as 90, which means equal to 90, or they can be greater than 90 as well. Okay. So that is the reason we are doing greater than and equal to 90. Okay. So all these 23% scores can be higher than 90, or they can be as high as 90, which means equal to 90, or they can be a mix of both. Okay. We have all these three possibilities when we say 23% scores are higher or as high as 90. So this is what the p-value is. So if I give you a data set and tell you that the p-value of scores greater than equal to 90 is 0.23, what you would understand is that 23% of these scores are higher or as high as 90. Which means that your score, which is 90, is sort of on the rare side, higher rare side. Okay, because rarer side can be lower as well. Okay, but since we know that the total marks are out of 100 and your score is 90 and the p-value is 0.23, so you can say that it is on the a bit higher extreme side. Okay. Now let us understand the concept of lower tailed p-value. Okay, so we understood upper tailed. Now let us understand lower tailed p-value. Okay. So this is nothing but the p-value of score less than or equal to 90. So how many numbers are less than or equal to 90? And for that we would like to find the p-value, which would be called as lower tailed p-value. Lower tailed p-value is nothing but less than or equal to. So upper tailed was greater than equal to, lower tailed is less than or equal to. So to calculate this, we need to find out how many numbers are less than or equal to 90 in our data set. So remember, less than or equal to 90. So we have around 11 of those. Okay, 11 of those. Total scores are 13 as before, and the simple way to calculate this is to divide 11 by 13. Okay, so that would give us lower tailed p-value, and this would be approximately 0.85, and you can do this now. So around 85% scores are lower or as low as 90. So similar statement that we made earlier, but instead of using the word higher or high, we are using the word lower or less or low. Okay, so around 85% scores are lower or as low as 90. Lower or as low as 90. So similar thing, when we say around 85% scores, what we mean is that 85% scores can be lower than 90, or they can all be as low as 90, which means equal to 90. Okay, but what you need to understand is that you can clearly have a look at the data and then say that when we say 85% scores are lower, and you can see the data, we can see that only one value is equal to 90 in those 11 values that we selected, and all the other values are less than 90. So you can say that your score is again rare on the higher side, because 85% of the scores are lower than your score, which means that you scored comparatively good. Okay, but this is called as lower tailed p-value because we are calculating the p-value for numbers to be lower than your reference value, which is 90 in our case. So lower less than equal to, upper greater than equal to. Okay, so lower low, less than, upper high, up, or higher or greater than. Okay, now a bit tricky one, which is two-tailed p-value. Let us understand two-tailed p-value. Two-tailed p-value. Again, you must be thinking, what is the significance of calculating these p-values? So this basically gives you a single representative number which tells you that how rare, extreme, or unusual your reference value is, because you calculate the p-value for a reference value, right, which in our case is 90, right? So it tells you how rare, how unusual, or how extreme that value is in a given data set. Okay, so that is the reason we calculate p-value, and that is the significance of calculating p-value. Okay, okay, coming back to our two-tailed p-value. So what it tells us is that how many numbers are as extreme as 90 in either direction from the middle. Okay, so when we say from the middle, we mean average. How many numbers are as extreme as 90 in either direction from the average of that particular data set, or from the middle. Okay, you can use median as well, okay, as a measure, but we'll use average because it's generally a good measure. It distributes everything evenly. Okay, are as extreme as 90 in either direction from the middle. Okay, what we mean by middle is average. Average is equal to 70. So if you calculate the average marks would be 70. So how far is 90 away from 70? Okay, 90 is our reference score. So how far is 90 away from 70. So how far is 90 away from 70? So 90 minus 70 is equal to 20. Okay. So how many extremes are in the upper tail? How many extremes are in the upper tail? Okay, which means greater than equal to 90. Okay, as extreme as 90. Okay, so yeah. Okay, so if we look at the data set, we have 95 and 100. So 90, 95 and 100 basically, which gives us three extremes: 90, 95, 100. So three extremes in the upper tail. Okay. Now, how many extremes are in the lower tail? Okay, so let's do 70 minus 20, which would give us the lower side extreme, so which is 50. Okay, so 50 is our first value. So 50, this is our first value on the lower side, which is like 20 away from the 70, which is our mean. Okay, so how many other numbers are there which are lower or as low as 50? So we have 45 and 40. So that gives us 50, 45, 40. Again, three extremes in the lower tail. Okay, so how many total extremes do we have? So total extremes is 3 on the upper, 3 on the lower, equal to 6 total extremes. Now two-tailed p-value is given as 6 over 13, which is the total scores, approximately 0.46. Okay, so basically what is the p-value of having 6 extremes on either direction which are as extreme as 90, okay, out of the 13 values, so which is 0.46. So the way we would phrase the statement is around 46% of the scores are as extreme as 90, either above or below the average. So around 46% of the scores are as extreme as 90, either above or below the average. Okay, so to summarize this, right, so if 90 is your reference score, okay, upper tailed value is this, how many scores are greater than or equal to 90. Lower tailed value is this, how many scores are less than or equal to 90. Okay, from an extremeness or rareness or unusualness perspective. And if we talk about the two-tailed value, right, and this is the our average score, which is 70, right. So when we talk about two-tailed value, we are trying to find out how many scores are as extreme as 90, either above or below the average. Okay, so we'll find out the difference, okay, which is 20. And since on the upper side we are already finding the difference from the reference score, we would just simply calculate this, okay, one side, and then we'll calculate this. Okay, so we'll find out the next value here, right? Whatever is the difference, which is 20 away from the average, and then we'll find out all these values. So these values, right, we'll sum these values, okay, and then over the total count. So that would give us how many values are extreme as 90 on the either side of the mean value. Okay? Because see, if you want to find out the extremeness on both the sides, you need to have a reference value which cannot be 90, because you are trying to find out how many values are as extreme as 90 on either side. Okay, right? So for the single tailed p-value, upper tailed or lower tailed, the reference was 90, but in case of two tailed, the reference becomes as 70 and 90 becomes as the distance that you want to go on either side. Correct? So 90 minus 70 becomes the distance that you want to go on the either side of the mean. Okay, that is what the two-tailed p-value gives us. Okay, so you scored good because only 23% scores are above you, which is the upper tailed p-value. However, the class's result is not good because almost 50%, which is very close to 46% that we got here, right? People scored far below average as those scoring high. 46% of the people scored far below average, okay, as those scoring high. Basically, two-tailed value will tell you how many people scored as extreme as you, either low or high. Okay, so if you see it that way, right, if you halve the 46, 0.46, you would get 0.23, okay, which was our value on the for the higher side, okay, which is as extreme as 90. Okay, now there is another concept that we need to cover, which is very, very important, which is the concept of threshold. Okay, and this is generally called as 5% rule. Okay, to categorize the value as rare or extreme, the p-value for that value or number should be less than 5%. So let me write this. To categorize the value, the reference value, in our case 90, okay, as rare or extreme within the data set, this is important. Given data set or within the data set is important. The p-value should be less than 5%. So remember, that is not less than or equal to, it should be less than. If it is equal, it won't be categorized as rare or extreme. But if it is less than 5%, it will be categorized as extreme or rare. Okay, and within the data set, given data set, this threshold is often called as alpha. It is often denoted as alpha. Okay, alpha. In our scores example, none of the p-values tells us that 90 is a rare or extreme score, because every p-value 0.23, 0.46, 0.85, okay, so this was upper tailed, this was two-tailed, this was lower tailed, right? Each value is greater than alpha, okay, right, greater than 0.05 or alpha or this. Okay, so we can clearly see that 90 is not a rare or extreme score. So what is the rule? So rule is, if p-value is less than 0.05, we can say that the value is rare or unusual. If p-value is greater than or equal to 0.05, not rare. Okay, we cannot categorize it as rare. So we'll extend this concept of p-value and alpha in our later videos in detail when we understand and cover the concept of distributions, right? But for now, this should be enough to get you an idea of what p-value is, what it does, when to use it, when you want to find out how rare or extreme your reference value is as compared to the other values in the dataset. You should calculate p-value. Yeah, another thing that I want to cover is it is different from percentiles. Okay, percentiles, you are trying to calculate that how many people scored below you or above you, right? And where you actually stand. But this is simply a measure of extremeness or rarity. Okay. Thank you for watching. Please like, share, comment, and subscribe. That will actually motivate me to create more videos. And if you want me to create a video on a specific topic, feel free to put a comment. I will try and cover that topic in my next video or upcoming videos. Okay. Thank you. Thank you for watching.